Dr. Richard Paulson from the University of Southern California, and I'm holding a soccer ball today as an analogy of what a human pre-implantation embryo looks like, and also to demonstrate why it is that when you take a few of these cells off, you may or may not always get the same answer. So most of us think of embryos as the sea urchin embryos that we saw in biology class. They have maybe 2, 4, 8 cells, something like that. But by the time the embryo is ready for implantation, it is a blastocyst, and it has actually blown up into a structure that looks very much like this soccer ball. It has an outer layer of cells, which is called the trophectoderm, in this case represented by the soccer ball. And then there's an inner cell mass that is inside that you wouldn't be able to see because it's inside, but that is the part that is eventually going to become the fetus. This is the part that's going to become the placenta. Now, one of the things that happens during rapid division is that as the cells divide, they may make a mistake. And they can either keep an extra chromosome or lose a chromosome that they needed, and therefore the chromosomal content of that particular cell is wrong, even if the rest of the embryo is okay. So think of this embryo as having been normal, and we'll use white as the normal cells since they're more common here, and the black areas as being the abnormal ones where the cells had made a mistake. You could see how if you go and you take a biopsy of a part of the embryo that you are going to get a different answer, and that it may not necessarily reflect the rest of the embryo. Most importantly, it may not reflect what's happening on the inside in the inner cell mass. Furthermore, when you do a biopsy on a blastocyst, you're removing about 5 cells, which in this analogy would correspond to about 2 of these faces. So you could get a black and a white, or you could get 2 whites, depending on where you do that. In addition, it gives you a sense as to how much trauma you would probably do to that trophectoderm by removing that many cells. And in fact, we do know that doing the biopsy like this does decrease the implantation rate. So even if you have a normal test and you're transferring that embryo, you have done some damage to that embryo, meaning it'll have a lower probability of implantation. And that is why pre-implantation genetic screening is probably not ready for prime time.